Hi, in this video, we're going to take a look at using a large language model for sentiment analysis. Now, GPT-4o Mini was released relatively recently, and this is my first time using it, and I like the results. It's pretty quick. That's going to be the model that we use. Now, for large language model sentiment analysis, something that is very, very sweet about this is that I have to do very, very little work. I just basically take my text, drop it in, does the computations, I get my results. Very little is on my shoulders for sentiment analysis. So that's a huge advantage to this. Also, from what I can tell, large language models do a better job of picking up the negation aspect than other techniques that we can go through that use like text flags. All right, so let's go ahead and just kind of work through this now. All right, so the advantages of using a large language model for sentiment analysis, first and foremost, is that they do a good job of detecting the negation. So here, let's look at an example. The doctor resolved my fears. Okay, so let's think about how some sentiment analysis techniques handle what's going on. Well, if we're using a text flag approach, I've got, well, the and my, those are stop words. I've got doctor and resolved and fears. All right, so doctors, resolved, and fears are the actual words that will be used for sentiment. Doctor, well, that's rather neutral. Resolved, I mean, maybe positive, but kind of a weak positive. But fears, fear is going to be a strong negative word. And so this sentence right here, with a lot of systems, would come up as a negative sentiment. Now, the reason for that is because the word fear is a strong negative word, and resolved may be positive, maybe a weak positive, maybe not even considered in our list of positive words. And so what would happen for a lot of systems is that this sentence, which is positive because it says, hey, the doctor solved my negative emotional state, should be positive, but sentiment analysis might pick this up, depending on the system, depending on which particular package module you're using, could pick this up as a negative because it misses the negation of the word resolved. All right, so, but if I'm using a large language model, it's going to pick this up. This one's going to be detected as a positive, or maybe a neutral if if it just interpreted that way. Also, another nice thing about large language models is that I can specify what I want as the response in my sentiment analysis. I can say, hey, just give me positive, negative. I want positive, negative. Or I can say, hey, classify it as positive, negative, or neutral, or give me a score. Here in this video, I'm going to do a score from -1 to 1 on the continuum, 0 being neutral. And also, we need to do very little data prep to get sentiment analysis going when I use a large language model. Basically, I pick a model, give it a prompt, give it the text. That's pretty much all I have to do. Now, there are some major disadvantages anytime I use Gen AI, and this is no exception. All right, so first and foremost, and this is one that gets under my skin, honestly, is that you're going to get inconsistent results when I take the same model, same observation, rerun it, I get something different. Now, what I've observed is that for sentiment analysis, generally speaking, we have pretty good consistency in terms of positive, negative, neutral. Scores a little bit more flexible, a little bit more inconsistent, but the explanation text that the large language model gives us tends to be inconsistent. And like generally speaking, we would like to have, if it's the same input, I want the same output overwhelmingly. Now, large language models also tend to be very verbose. All right, so in a moment, I'm going to show you that it explains why it's positive or why it's negative or why it's neutral. And that might be really good. That might be really helpful for what I'm working on. But honestly, for this project here that I'm for creating this video, I just wanted positive, negative, number. I just want a number. Just give me a number. I don't care about the rest of it. And so that extra information is something I actually have to put extra effort in to remove and get rid of. You know, a lot of times I just want you to spit it out, give me the answer, don't give me the rest. Large language models don't really support that very well. You can modify your prompt to address that, but my experience working with large language models is that doesn't work out. Even if you tell it, don't do this, if I'm doing a whole data frame full of observations, a few are going to still get in there. Long computation time. This is no joke. It took a long time to get this to run. What I'm going to show you, I've got 50,000 observations from the data set. It's movie reviews, and it took a long time for it to go. So if I only need a few, this is not a problem. But if I need a large data set for sentiment analysis, honestly, I'm probably not even going to consider a large language model. It's just going to take too long. Also, another one is that we'll need to pay to use the API if I'm going to be using OpenAI. Now, GPT 3.5 Turbo and GPT 4o Mini are cheap. They're really, really cheap. And frankly, I think it, you know, I think OpenAI really is delivering a lot for very little cost on my end. And they're also pretty fast. So I this could be a real issue if, let's say, I'm at like we determine that OpenAI is the right way to go. I don't want to use like Hugging Face, maybe like security concerns, or my office, my organization hasn't vetted different models I would like to use, and for one reason or another, I have to use OpenAI. But then it might be that in my office I can't get funds, right? I have to have somebody provide a credit card to OpenAI to be able to charge. And even if I'm only going to charge $10 to get things going, it might be a huge bureaucratic battle for me to be even get this started. To get 1 cent out of the organization might be a huge long process, depending on who you are. Now, if I'm the CEO of the company, it's nothing for me to do this. But if I'm a data scientist and my organization, has a tight grip on the budget, or the supervisor who I need to go through just as being difficult on it, this could be a huge problem. And now Hugging Face, all the ones I've worked with, I didn't need to pay for anything. But it might be that for your project, because of like security concerns or accuracy hallucinations, organizations are coming up more and more with like guardrails and restrictions and requirements on Gen AI. And in that case, you might get railroaded towards certain solutions. Also, something, and this happens like on every single time I try to use OpenAI, I swear. So large language models are going through rapid development. And so one thing that I find about Python is that there is a lack of desire to be backwards compatible. I started out data science in R, and I'm currently working in Python. R, I mean, they are really good about making sure that things are backwards compatible. Also, base R is really, really old. It's really not developing much anymore. And when a package goes through development, a lot of times, even if it's a depreciated function, the package will keep the depreciated functions in there and just say, hey, warning, this is depreciated, but my old code will still run. That way I can just keep it going. From what I've seen in the Python community, and this is an issue at work right now, is that they'll change something, and to me, it looks like they change it purposefully to make it not backwards compatible. Well, if I need my code to be able to sustain over a decent time span, this is a huge problem. Also, the whole large language model method is that I'm giving a prompt, and I'm giving it the text input, and it figures out the rest. It's very black boxes. I don't like, I can control my prompt and I can control my input text, but beyond that, I don't really have a whole lot of control on what's going on. It's not like I can do feature selection and feature engineering and check for interactions and invoke regularization. Like I can't change weights, anything like that. And so if the model isn't good enough, I really don't have a lot of tools to address that. It's like I'm just, to a large extent, I'm stuck with it. I can change my prompt, but my experience is that changing the prompt will improve things, but not completely resolve problems. Also, Gen AI can have problems with hallucinations, bias, and toxicity. So this is a huge concern of any meaningful organization. It's better to not make a mistake than to do well. And because of that, organizations are skittish towards using Gen AI, and they're going to have a lot of oversight on what's going on. A lot of guardrails, you're going to have to go through a lot of permissions. And so this will make it so that honestly, a Gen AI solution probably isn't worth the headache. There are super major advantages with large language model, but honestly, if I have to go through and get every single step approved, it's gonna slow down my process. If for me to make progress, I need to have a meeting with somebody every single week, and they go on leave or something happens. The CEO calls a meeting, something happens that prevents us from meeting, that can completely roadblock my project and I can't make my timelines. All right, now we can reduce our wait time by using batch processing, asynchronous results, and by handling errors and logging by basically just skipping errors and reducing the amount of logging that we're doing. And so these are some options we have to improve. Um, what I recommend doing is that, let's say that I know I'm going to use the latest and greatest model. Now, that latest and greatest model is going to be the most accurate, most reliable for the output, but honestly, it's a very complicated model. It's going to be slow. What I'm going to do for development, I'm either going to use like GPT 3.5 Turbo, or I'm going to be using GPT 4o Mini because they're fast and they're cheap. And I just want to have like a placeholder to show me how things are going to go. So I would use a very fast model and as fast, through the development process. If that model isn't good enough, then all right, we go ahead and just slap in the latest and greatest, and then we get the best result I possibly can get, and then we proceed forward. Because if I'm sitting there waiting for things to compute, I can't really progress on my project. And also, if you're going to fail, you want to fail fast. All right, so let's go ahead and work on this. So here I'm going to use the IMDb data set. So this is a large movie review data set. This is a binary sentiment classification, substantially more data than previous benchmark data sets. So it's got 25,000 highly polarized movie reviews for training and 25,000 for testing. Now there's also an unlabeled data set. I'm not going to use it all here. It is available. I just have to modify the code just a little bit to be able to get it. Yeah, so here is the information for citing it, by the way. Okay, so now what I did, long computation time. I went through and as I did my sentiment analysis, it takes a while and I've had problems with like the kernel timing out, losing connection, maybe a storm hits, I lose internet for a second and my code gets an error, in which I've lost everything, all the computations up to that point. So what I did, I'll show you in a moment, is that I give it text, I get the response, I save it. Text, response, save it. Text, response, save it. Now, this isn't the fastest way to go, but this makes sure that I'm not having any duplicate efforts. And so here, this is my code for loading the data. You'll notice that I've got these two cells are raw instead of code. This was the code that I used, but I've I saved everything in a CSV, and I'm going to be just using that CSV here because I've got it. It just takes too long to go through everything. So here we're using the datasets module. It's the IMDb. And so now when I do this, I'm going to have a trained dataset, a test dataset, and there's also an unlabeled. Well, for our purposes, I'm not training a model. It's just all the data. So I'm just going to go through and run all my data, and I'm just going to treat everything as the test dataset because this is what I have. Because I'm not actually fine tuning a model. If I was going to go through and fine tune, then I would have a train validation and test set going. I would take my train data and split that into train and validation and leave test as is. All right, so I'm going to load the data. So this is after I got done doing all the sentiment. I saved it in this spot on my computer, and I'm just going to show you what it looks like when I got to this point in the original code. You see here is the code, and here is the label. And so we have 0 and 1. And so one is positive, 0 is negative, and all the labels are 0 1s, binary classification. There is no like 0.5 for neutral. It's either negative or it's positive, nothing in between. All right, now here I'm going to go through and define the function that I'm going to use for getting my sentiment. Now you will need an OpenAI API key. And so you put that here in this position. And for this, we're using it's client chat completion create is really the workhorse of this notebook. The model here, I'm using GPT-4o mini. And what I'm going to do is the role is system. And my prompt is that analyze the sentiment of the text and rate the sentiment from -1 to 1. 1 is super positive, -1 is super negative, 0 is neutral. And then here is the text is going to be entered into the function, and it gets put into this dictionary. Notice that I've got in my message parameter, I have a list of dictionaries going on. And then I'm going to have the response coming out. All right, so what I did was my first step is I created a column of strings of empty strings. Now it's commented out because, as I go through, I stopped, I checked to make sure that the code was functioning as intended, and then I would get back to it. So initially I, made a column of empty text, but then after that, I leave it alone. All right, so now this code here, there is some redundancy. What this is going to do, this is going to go through every sentiment analysis or every entry of the sentiment column, and if it's empty, it's going to execute the classify sentiment function for me. And then after I get the result, it saves it. Also, something that I did was if there's an error, just roll right over it. Don't even tell me about it. I can go back afterwards and check to see, well, which ones didn't work. If I know, I know that anything that is an empty character string after I'm all done, I know that those are the ones that that the code did not work out for. And so I know that there was an error and I can figure out what's going on. I have 50,000 observations to work through. I don't want to stop because 2 or 3 give me errors. All right, so let's go ahead and take a look at what we've got. And so here, the sentiment of the text can be rated as 0. And then the next part, it actually gives an explanation as to why that it gives the result it did. So actually, let's take a look at this. Yes. So I want to show you a full. All right, so the reviewer expresses a neutral perspective throughout the commentary. I am curious yellow. While they acknowledge the film's controversial past and its significance in context to Swedish cinema, they are critiqued in plotlessness and discuss the nature of its sexual context without strong emotional attachment, reflecting a balanced view rather than an overly positive or negative sentiment. Now, if we look at the original, we can see what the original values are and what it looked like. To me, this is a rather proportionately long output for what we have here. You know, like, you know, this is shorter than the original text, but it's like it's a decent explanation. Honestly, all I wanted was 0. That's all I wanted. I just want you to spit it out, give me the number. But if I wanted, if it was important for my project to be able to get that feedback and that understanding, I know why the large language model reached the conclusion that it did. All right, so after I have all of this in here, so I'm gonna do this. So I have all of this text to work with. All I want is the 0. So what I'm going to do is I'm going to use a regular expression, and I'm going to extract all the numbers, the digits, and positive, negative signs from there. So I maybe not want a positive or negative number. Like here, I don't have a positive or negative symbol. I want if I have a number and this is a 0 or more of a number, then I have a decimal, and then I have one or more numbers. So you'll notice that it's actually rounding off, or actually it's truncating. It's not rounding off, it's truncating the score instead of rounding. Okay, and so now on this, what I'm going to do is I'm going to double check to make sure that everything is between -1 and 1. If I had a 2, if I had a -3, something like that, then probably, let's say, we're talking about the movie 12 Monkeys, something like that. All right, well, if the number is 12, that's not a sentiment. So I went ahead and said, hey, if it's not between -1 and 1, kick it out, get rid of it. Now, there are explanations where it says, well, because of this, this part of it, the rating should be a negative, 0.8, and this part of the rating should be a positive 0.75. And so there are multiple numbers that appear in the actual rating. There's actually just one in there. I've got 50,000 observations. I don't want to go through and individually pick through. So what I chose to do was take all the numbers and just do the median of it, rather than giving me a full list of numbers on each observation. All right, and so here I can see what the actual sentiment score is. I'm calling it extracted sentiments. Now let's evaluate the model. Let's take a look at the actual performance. All right, so here we can see that we have kind of like two extremes, kind of looking, it's kind of shaped kind of like a beta distribution from -1 to 1. Classic beta is from 0 to 1, but this is -1 to 1. We could rescale it if I wanted to. But we see some over here that are negative, some are positive, and the data set description tells me that these are extremely positive or extremely negative reviews. And so here, this may be a problem, that there's this 0 aspect. It might be that like that first one that gave us a 0, other sentiment analysis systems may call that very positive or call that very negative. We could dig into it. So given the description of the data set, this is more zeros than I would have anticipated. All right, so now I'm going to take a look at the box plot of the extracted sentiment by the actual correct label. And so here, the label in the data set is negative, the label in the data set is positive, and so we can see with the box plots that overall, the model is picking up a consistent score with the label, but it's not 100%. You notice that with all of these outliers, so anything less than 0 is going to be called a negative. So when it's called positive, overwhelmingly, the model is calling it positive also. Now, when we look at the negative comments, though, No, the story isn't as great of a results for the model. That it's a negative label, and we can see over 25% of the observations got labeled as positive or neutral. Okay, so something that we might have to, like I would want to like dig into this before I would consider using GPT-4o mini. It might be if I change to GPT-4o, this might resolve, but I would have to like make choices about funding and computation time to be able to use that. All right, so let's go ahead and do a confusion matrix off of this. So the original labels are 0 and 1. I took the sign of the results, so -1, +1, and 0. And so we can see that we got overall pretty good consistency, but not 100% consistency. So we definitely want to figure out what's going on before I would launch this. It might be that my model might be actually doing a better job than the actual labels in there when I go through and start reading individual entries. And so now let's go ahead and look at the ROC curve. Now, isn't that the most interesting ROC curve you've ever seen? So for very, very, very low threshold cutoffs, for calling it positive, it's equal to random guessing. And then it comes up and looks like that. And this is a much larger ROC curve than I anticipated. It's a 0.81 AUC for this. Super surprised. I thought this would be much lower, but we can see that we definitely would not want to use a very low cutoff for positive to declare something as positive. All right, I hope you've enjoyed this video. Large language models are definitely exploding right now. You definitely want to be working with this, learn this. Gen AI is going to leave us in the dust if we don't study this and master this. And well, that's all I've got for you. Life is short. Do math.